Today we're going to look at finding volume of rectangular prisms. This is something that you have done before using a formula that you learned in elementary school. Today we're going to talk about a little bit different of a formula that's going to prepare you for the volume of other figures in the future. So our focus will be on volume of rectangular prisms, such as a Kleenex box or a television or a pool or an aquarium. But in the future, you will have to learn how to find volume of other things, such as cylinders and prisms and pyramids. So you used the formula length times width times height when you were in elementary school. But we're going to change that slightly now that you are in middle school. The formula that you're going to use is that volume equals what I call super base times height. And all super base means, this capital B, this means the area of the base. So I know we're using that word base in a couple of different ways, which can make things confusing. But when you look at a rectangular prism like this, your base is going to be this flat part that your figure is sitting on. And so what we have to do first is find the area of that base. And so that B, which means area of the base, really is just where you're multiplying the length and the width, or the base and the height of that flat piece that it's sitting on. So as we've done with other area models and area calculations, you are going to be required to show your work, and that first line is going to be your formula. So I'm going to put that our volume equals super base times height. And really what that base means is this 2 times 6 that we're going to be looking at. So what I'm going to do is I'm going to substitute that in for super base on my next line. So I'm going to substitute in 2 times 6 for my super base, and then my height, I'm going to use this 1.5. So then my next line, of course, is going to be my solution. So as we've done in the past, we have our formula, we have our substitution, and then we have our solution line. And so I know that 2 times 6 is 12, but then I need to multiply that 12 times 1.5, which is something that I expect that you should be able to do in your head. 12 times 1 is going to give me 12. And then if I multiply 12 times 0.5 or 1/2, that's 6. So 12 and 16 then gives me 18. So in this case, my answer is going to be 18 inches cubed instead of squared. When we find area, it's squared because we're doing inches times inches. But here, inches to the third power means inches times inches times inches, which is what we did. We did 2 inches times 6 inches times 1.5 inches. So we write this shorthand style by making it inches to the third power. So let's look at one more that we are going to do. Let's look at this cube here. So our volume is going to be super base times height. Then our volume is going to be the area of the base for our super base. Well, it's a cube, so all of the sides are the same. So it's going to be 6 times 6. And then our height is also 6. So we know that 6 times 6 is 36. We might have to work out 36 times 6. There's nothing wrong with that. 6 times 3 is 18. 18 plus 3 is 21. So then our volume ends up being 216 inches cubed. Remember, it's to the third power. You do have an assignment on formative today. You will be turning your work in. I will need to see these 3 lines of work. You are going to need doodle space today. All of these problems, I'm going to need to see your long multiplication as well. Because if we're still making those multiplication mistakes, I want to be calling you in so we can get those things fixed.